All right, so today we're on 6.5 and we're talking about trig ratios. So this is something that is probably going to look a little more familiar to you because you did a lot of this in geometry. Now I'm going to carry this lesson through from pre-cal vocabularies, and then maybe I'll tie it in a little bit back to what you did in geometry. So the bottom line here is that trig functions, the whole purpose we're doing trig is that we want to relate an angle, and this angle is this shape theta, and you've seen me draw it, but we want to relate this angle to the ratio of two sides of a triangle. Now right here, super important, this right triangle. So just kind of a little bit of review. If we look at just our coordinate plane, and I'll just put this in the first quadrant, but if we have this angle in the first quadrant, we know that this is the initial side, we know that this is the terminal side, and we know that this angle right here, this angle theta, is going to be my reference angle. Okay? Now, what I can do with this is I can turn this into a right triangle. And to turn this into a right triangle, I'm going to drop this drop a perpendicular line here to the x-axis, and this becomes my right angle. So we did this when we created reference triangles. So we did this in a previous lesson. We have reference triangles. And so what we do is we have this right triangle. Now when we have this right triangle, we have our x component, and we have our y component, and we have this component that's here, that's our terminal side, and this is our hypotenuse. Or what we would say, because most of you are probably in physics now, we would say that this right here would also be our vector radius. So we talked about it in geometry in terms of your hypotenuse, but this terminal line here would also be your vector radius. So we have x, we have y, and we have our hypotenuse or our radius. So you'll see here that hypotenuse and radius, I interchange these two just kind of depending on my mood. So you can feel free to do the same. So what we have here is when we define this, we're not going to think of this in terms of SOHCAHTOA. That's what you did in geometry. We're going to think about this in terms of trig. So what I have here is that my sine function is going to be the y component of my reference triangle over my hypotenuse. Now I can also say y over my vector ratio, because remember what we're doing in trig is everything that we have is a circle, and so this is a radius. So when I have y, my y component, right, so that's my vertical component over my radius. So cosine is always going to be x over r, and tangent is always going to be the y term over the x term. All right. Now, we have these reciprocal functions. I don't know if you studied these in geometry, but the way that a reciprocal function works is it is the opposite of the parent function. So if my parent function is sine, the reciprocal function is cosecant. So this is cosecant. So cosecant becomes r over y. So I'm literally just flipping these two to get my ratio. Remember, this is a ratio of sides. So SEC is secant, and that's going to be r over x. And cotan, this is cotangent. So cotangent is the opposite of this. So cosine goes to secant, tangent goes to cotangent, so this becomes x over y. So just a silly way that I remember these, because you know I always have to have some little thing, is that if you look, this is an S, and this is a C, and this is a C, and this is an S. So it's kind of opposite of what you would think. So the S goes with the C, and the C goes with the S, and then tangent, cotangent, that's pretty easy. The tangents stay together. Okay, so now that we know these ratios, what we're going to do is we're going to go in here and we're going to solve these. So this says the terminal side of an angle in standard position passes through the point -3, 4. So if I draw this coordinate plane right here, I know that this is x and this is y. So I go over here 3 and I go up 4. So I have a point that's right here at -3, 4. And it says the terminal side of an angle in standard position. If it's in standard position, it's the positive x-axis and it's going to go this direction. So that's what my angle is going to look like. Okay? Now, if I'm looking for my reference triangle, my reference triangle goes with my reference angle, and the reference angle is the closest angle to the x-axis. So this becomes my reference angle, and this becomes my right angle. So this is my reference triangle, this blue and pink triangle that I have right here. Okay, so what I want to do now is define my two sides. So my x side is -3, which makes sense. It's in the negative x direction. And my y is +4. It's in the positive y direction. So now I have my x, I have my y, and I need this value of r or h, depending on what you want to call it. So this value here, which is our radius. And so to solve this, it's just the literal Pythagorean theorem. So I'm going to have -3 squared plus 4 squared equals r squared. And be careful, make sure you know what you have. So I have x and y, so that goes on this. R is the same as my hypotenuse, which is always the side opposite of the right angle. So that's the one that gets to be by itself. So I have 9 plus 16 equals r squared. So r in this case is going to be just 5. So square root of 25 gives me 5. Okay, so now I look at these ratios. And if I look at these ratios, if I look at sine, I know that sine is my y value over my h, or my y value over my r. Well, my y value is 4, and my r value here, we just calculated this, is 5. So this becomes 4 over 5. Cosine is my x value. Well, y'all look at this. My x value here is negative. So when I have cosine in the second quadrant, my value for cosine is always going to be negative because this value of x is negative. Okay? Tangent is y over x. So I have 4 over -3. Now, remember these are opposite, so sine goes with cosecant. So I'm just going to flip it, 5 over 4. And cosine goes to secant, so c goes to s, so -5 over 3. And tangent goes to cotangent, so -3 over 4. It's as easy as that. All right, let's try another one. If cosine equals 5 over 7, so I have cosine as 5 over 7. And what I know about cosine is this is the x value, and this is my r value, or my h value. Okay, so it says theta is the angle in standard position whose terminal side lies in the 4th quadrant, and the value of sine is, find the values of sine. Okay, so here's what I have, and I know that this is going to be in the 4th quadrant. So I have this point 5, 1, 2, 3, 4, 5, and I have some value down here, I don't know what this is, of y. So if this is my x value, then I go over here to x, and this is my hypotenuse, or my radius, so it's going to look like this. But I don't know yet, I don't know what this value is. I know that this is 7, but I don't know what this is, so I have to calculate it. So here's my right angle. I didn't draw my reference angle. I should have done that. So here's my reference angle. So here is my right angle. This goes across from my right angle. So when I go to solve for this y component, I have 5 squared plus y squared equals 7 squared. So remember, if you have, you're not always going to set it up so it's on the same side. So what this becomes is y squared equals 49 minus 25. So y squared equals 24. So that is not a pretty number. So what I have here is the square root of 24, and I'm going to use 4.9. So I'm going to say y equals 4.9. So what does that mean? That means this value right here, 1, 2, 3, 4, 5, this value right here happens at 4.9. That's what this is saying. So if I want to know my sine value, sine is y over r, so this is going to be 4.9 over 7. But watch out, because what happens is this is a negative y value. So when I go negative here, based on this quadrant, this value of 4.9 is actually negative. It would be positive if it was in one of these quadrants up here going up, but this isn't. This is going down. So because it's going down, it's negative 4.9. And then my tangent is y over x. So my y value is negative 4.9, and my x value here is going to be 5. Now, I know that this is not correct math. I know you cannot have a decimal in a fraction. I know that. I could have also said, all right, if this is y squared equals the square root of 24, then I know if I simplify this, 4 and 6, that y here, sorry, fy squared, this is y, if I take the square root. So y here is going to be 2 square root of 6. So I could also write this as negative 2 square root of 6 over 7, and then negative 2 square root of 6 over 5. So this would actually be correct math because I'm using my radical correctly, but I was lazy. I plugged it in the calculator. But if you want to solve it with a radical, these two things are the same. Okay. The concept here is understanding your trig ratios, right? We are not using SOHCAHTOA. We're going to, but right now we're just identifying this in terms of x and y. And y'all, in physics, this is super important. You've probably already covered this. You've already probably covered that cosine is always your x direction, sine is always your y direction. We have two vectors, so forces in x and forces in y. So you've probably already covered this in physics by this point of the year, okay? All right, moving on. That's all we've got in this lesson today.